So, one last section in this chapter, the specific heat and thermal conductivity of the body. Your book goes to an example of, of a feverish person with 104-degree fever, so 104-degree Fahrenheit fever, which is about 40 degrees Celsius. Remember that the standard temperature of the body is 37 degrees Celsius. You put them in a tub of water to cool, because when you have a fever that high, it can be dangerous. And so you put them in a tub of water to cool. And I want to know how much energy must leave that body in order to cool properly. So this is a simple calorimetry calculation. Q equals to mc delta T. Our mass of our person is about 70 kilograms. The specific heat of a person is a little bit less than that of water, or about 0.84 kilocalories per kilogram degree Celsius. Remember, the specific heat of water is 1 kilocalorie per kilogram degree Celsius. And then our change in temperature is going to be the final temperature, which is 37 degrees Celsius. That's the temperature that we want to get to. And the initial temperature is 40 degrees Celsius. So my Q is going to be a negative 176 kilocalories. That's the amount of energy that I want to leave. This is a lowercase c. Also, I just want to say here that this negative means that this is energy leaving the system. That's the amount of energy that we want to lose. So now, if I think about how this leaves the body, this occurs through conduction. And by the way, I'm going to show you this calculation or just sort of give you this example, but I won't have you do this calculation. But I do want you to know how the rate of conduction, the energy conduction is related to these various variables. So if you think about the body, you can think about it sort of as a, here's my really bad body. I don't even know what that is. There we go. That's sort of right. That I have this inner part of the body that's hot, and this energy is leaving through the skin and going out into the surrounding area. So if I think about the body in a really simple way as that, where all the energy is leaving through the skin, then the thermal conductivity of the skin is about 0.2. The area of our skin for a person is about 1.8 square meters, and the distance to go through the skin is about 1 centimeter, and then my change in temperature is going to be 20 degrees Celsius. That assumes that I have a bath with a temperature of about 40 degrees Celsius. Okay, so if I do that and I do this calculation, which again I'm not going to require you to do, but I find that the rate of energy loss is about 720 watts. Remember we saw a watt before. Watt is equal to a joule per second. Okay, so energy imbalance. Just wrap up this chapter. If you use more energy than you consume, that is given to weight loss. And if you consume more energy than you use, that's weight gain. And so at its very core, weight management is very simple, that you just use more energy than you consume. But of course, many factors can contribute. That high-carb diets can lead to weight gain, actually changing your body chemistry. As those carbs change into fats. And then also, of course, there can be genetic, I don't want to say issues, just genetic facts about you that may make this more difficult.